Vanita, finish. Vanita, have you finished?
Yes, please.
Okay. So what did you get?
18.03 Newton.
Okay, so this R squared is equal to F1 squared plus F2 squared. R therefore is equal to square root of F1 squared plus F2 squared. And so we have 10 squared plus 15 squared. This is equal to 100 plus 225, which is square root of 325. And what's the square root of 325?
18.03.
Okay. 18 point. $18.06. R is equal to 18 points. So, Regina,
Yes, please.
what did you get for the resultant?
Please, I had 18.03 degrees.
Then let's also find the direction of the resultant force. Of the resultant direction. When you look at F2, the force F2 was measured on the x-axis. The force F2 was put on the x-axis. Please, I hope you can see. So
Yes.
if we look at an M2, the force F1 is also put on the y-axis. So whenever the question is about direction, you look at the direction of the resultant force from the x-axis or from the y-axis. Okay, the direction of the resultant force either from the x-axis or from the y-axis. If we are looking at the direction from the x-axis, if you are looking at the direction of the resultant from the x-axis, then this is it. Of course, this is the x-axis. So this direction, this is the resultant vector. And when you see is going upward. Okay. So what we measure. So if you are looking for the direction, we can take it from the x-axis or from the y-axis. Both ways will do. Is that okay? So if it is from the x-axis, then this is the theta. This angle between the x-axis and then the result. Regina, are you fine? All right. So since we know every part, we know F1, we know F2, we know F1, F2, and R. Here we can use any trig ratio to find it. So if we take tangent of the angle to the x-axis, tan theta, tangent is opposite, which is F1 over adjacent, which is F2. What is F1? F1 is 10. F2 is 15. When you divide it further, 10 divided by 15 is 2 on 3. Okay, change 2 on 3 to decimal for me. What is 2 divided by 3 in decimal figures? Yes, Eliana.
0.667.
Okay, so we have tan theta. Theta therefore is equal to the tan inverse of this decimal value 0.667, and that is equal to what?
33.69.
So, to the nearest degree, 33.4. So this is the angle the resultant makes with which axis? With which axis?
The x-axis.
Yes. Now, if you are looking for the angle this resultant makes with the y-axis, look at something. The whole this from y to x. What is the total angle there? From the y-axis to the x-axis, what is the total angle there?
90 degrees.
Good. So if this is 34, and the whole angle is 90, Regina, what would be this angle to the y-axis? Regina, if this is
24.
Go. So you only subtract this from 90. Is that okay? And that will be, I think, 56. Okay, that will be 56 degrees. So what it means is that if you are looking for the direction of the resultant from the y-axis or from the north, then you have to turn through an angle of 56. If you are looking for the direction of the y-axis from the let me take it again. If you are looking for the direction of the resultant from the x-axis or from the east, then you have to measure 34 degrees from the east. Okay, so all these two options are direction. Are you okay? So that's how to determine direction. Any question? Okay, then let's look at another situation when we have two forces and the angle between them is acute or obtuse. When angle is acute, and here the angle lies between theta lies between 0 and 90 degrees. An acute angle is an angle that is greater than 0 but less than 90 degrees. So theta is between 0 and 90. Are we fine? Okay. I'm coming. Okay, so if theta lies between 0 and 90, then we have two forces. F1. Let me manage the board for you. I'll be doing a lot of writing, so let me manage the board. Ebibia and Akofala, you are welcome.
Thank you, Mr. Jia.
The late Akofala and Nabibia. So this is theta F2. So you can clearly see from the board that the angle between them is less than 90, right? So if you have this situation, how do you determine the resultant? Here we resolve the first method is that resolve forces into parallelogram. So you have to first resolve the forces into a parallelogram. And what is a parallelogram? Yes, to any of you, what is a parallelogram? Anybody can share what you know about parallelogram with me. What is it? You start with it is Mirabel, what is a parallelogram?
Mr. Jia,
Yes.
please can you repeat the question?
I said, what is a parallelogram?
Parallelogram is
A four-sided figure.
okay.
I beg you, please give me 2 minutes. I'm coming, okay?
Okay.
Yeah, I'm coming right away. So please think of a parallelogram. When I come, I'll ask any of you. Okay, I'm teaching, don't disturb me. Okay, I'm back. So, Akofala, what is a parallelogram?
Mr. Jia,
Yes.
parallelogram is a quadrilateral with opposite sides and angles equal.
So, to the rest of you, a parallelogram is a quadrilateral with opposite sides equal and parallel. Maybe I can't say your parallel. Okay. So for a quadrilateral, opposite sides are equal, but they are also parallel. And then opposite interior angles too are equal. Are you there?
Yes, please.
Opposite interior angles too are equal. So we resolve this into a parallelogram. And in doing so, I create an equal version of F1. Okay, I create an equal version of F1 and put it on the head of F2. Of course, for F1, This is the tail, this is the head. So I'm going to put F1 on F2. But what I'm going to put on F2 must be equal as F1. And they must be parallel. Okay? The two must also be parallel. So you have to draw a line, but you have to ensure that this two lines, this and this, are parallel. So long as this has the same magnitude, this one has the same magnitude as this, and then the direction of this is the same as this, and the two are parallel, they are equal. So if this is 5, this must also be 5. And you don't change the direction. It needs to have the same direction as this. I also create another one, F2 on the head of F1. Okay, equal version of F2 on F1. And this is how it must look like. The same thing as I've done. Same magnitude, same direction. So this is also F2. This is F1. This is F2. Look at what I've done. I've created a four-sided figure with opposite sides equal and parallel. This side is also equal and parallel. And this is what we call as a parallelogram. Mirabel, are you fine? The late Linda, you are welcome. So you realize that this plus this is coming here, this is going. So you could see that, oh, okay, if this and this follow a sense of order, then when I draw a line from the tail of F1 to the head of F2, it will give me the result. So this line becomes the resultant. Now, vector addition is commutative. Vector or addition of vectors. Vector addition is commutative. This is why we say that vector addition is commutative. You remember that is equal to this plus this. F1 plus F2. The same R can also be taken by 2 plus F1. So F2 plus F1. And because of this, we said that vector addition is commutative. Don't forget, 2 plus 3 is equal to 3 plus 2. It doesn't matter the order. Are we fine? Are we fine?
Mr. Dia.
Hello.
Ask a question.
Okay, ask.
He says in this case, we don't directly add it, like the way it has been presented.
Yes.
Or please, do you mean in this, if it were a scale drawing, this is what it would be?
Exactly. If this had been a scale drawing, we can easily determine the resultants by, okay, you see, in a scale drawing, what we do is that you use a ruler and scale to get F1, F2. Then, after getting that, if you measure from here to here, what you have will be the same as F1 plus F2 for scaled drawing. Are you okay?
No, please, Mr. Dia.
Hello.
The resultant, you mean that when you make a scale drawing of F1 and F2,
yes,
the magnitude of R,
yes,
the same as the numerical value of F1 and F2 put together?
Exactly.
But that scale it's still equal to, let's say it's 10 Newton, it's still 10 Newton.
You see, what we mean by scale drawing with scale drawing, if I'm giving F1 to be equal to 5, F2 to be equal to 6, okay, then I set a scale that, okay, let's, on your graph, let every 2 centimeter represents 1 Newton. So for 5 Newton, how many 2 centimeter boxes will I take? 5. Is that okay?
Yes, please.
So that will be on a scale drawing, this will be for F1. Every 2 centimeter represents 3. Then I come to F2. F2 is 6. But you see, you have to be given the angle between the forces. Maybe the angle between them is 30 degrees. So after measuring 30 degrees, if this is 30, then I measure F2. F2 would be a 6 Newton. So how many 2 centimeter boxes do I choose? 6, is that correct?
Yes, please.
Good. So 6. I'm only assuming if this is there, 6 centimeter, this thing we have to take. So 6.
Yes.
Then, you see, their directions are not aligned. So what you do is that there's the end point. You measure an angle of 30 degrees here. 30 degrees to get all that we are doing is I want to put this on, put F2 on F1. But the angles must be equal. That's why we are remeasuring 30 degrees here. Are you fine?
Yes, please.
Good. Then you get an equal component of this one. So this is also 6, maybe 6 Newton. Then I do same for this one too. Okay, I do same for this F1. Are you with me?
Yes, Mr. Ada.
Then I have this. So this is F1. This is F2. Go. Now, after doing this on a scale drawing, okay, now we have realigned the direction, their direction. I can now, to get the result, and all that I do is that, okay, then let me measure from here, from the tail of F1 to the head of F2. So I measure. When I measure, this length should be equal to F1 plus F2. Are you okay?
As in terms of centimeters.
In terms of,
Then
you see, in terms of centimeters, but don't forget, you are using a scale. You are saying that let 2 centimeters represents 1 Newton, right?
yes, please.
Good. So let's assume I measured 10 centimeters. Or I measured, don't forget, this is a huge value. So let's assume I measured maybe 20 centimeters. But I'm saying that let every 2 centimeters represent 1 centimeter. So that means that the resultant will be equal to 10 Newton.
10 Newton.
Okay, I'm just assuming.
Yes. But Mr. Ada, what I want to understand is that you are saying the resultant is equal to F1 plus
F2.
As in, so F1 is 10 centimeters. Then F2 is 12.
Yes.
Does it mean if we add the scales, which is 22 centimeters?
Yes.
That means it should be 11 Newton.
Exactly, that's what I'm saying. Okay, but you can do that by measurement and doing it according to the scale. That's what I'm saying.
But whichever you do, you should get the same answer.
Exactly.
Thank you.
Okay, so that's what we mean by now over here, because it's not a scale drawing, I cannot easily dwell on this to say that then the resultant will be F1 plus F2. Are you okay? Because this is not a scale drawing, I cannot conclude that the resultant will be F1 plus F2. If it's not a scale drawing, then you have to use formula. Ladies, are you fine? So
yes, please.
Let's look at the formula to use. I think I'll bring a question on as where we have to use a scale drawing, then we do it and see. Is that okay? And I hope you are there.
Yes, please. Mr. Diab, please, I have a question.
Okay.
Please, did you say that a parallelogram has two of its interior angles the same?
Yes.
Okay.
You say this angle and this angle are opposite, right? And they are always the same. This angle and this angle are opposite, and they are always the same. So with a parallelogram, two opposite interior angles, every two opposite interior angles are equal. If this is 30, this will also be 30. If this is whatever, this will also be whatever, right?
Yes, please. Thank you.
All right. So, because this is not a scaled drawing, we use the cosine rule. Use cosine rule to determine the resultant. What is the cosine rule? The cosine rule is that if I have any triangle, it can be a right angle triangle, a scalene, and equilateral. If I have any triangle, let me change my mind. I have any triangle. Mirabel, are you there?
Yes, please.
Okay, this side is A, this side is B, this side is C. Now, this angle is alpha. This angle is beta. This angle is gamma. Gamma, I said YB. Okay, any triangle, and I want any side. Let's assume we are looking for the side A. Then the rule says that the square of this side we are looking for, A squared, must be equal to the sum of the squares of the other two sides. So the other two sides are B and C. So B squared plus C squared. It is so similar to right angle triangles. The sum of the squares of the other two sides. But there is something added to it. Minus 2 times the product of the two sides, B and C, times the cosine of the angle opposite to the side that we are looking for. And we are looking for the side A. So which angle is opposite to the side A? Yes, to the audience. What is the angle opposite to the side A? Lenda Munkasa.
Why?
Why? But it is, your friend. We are calling it as gamma. All right.
Please.
Okay. So this is the cosine rule. Now, if I want B in equation, oh, it's just a matter of making B the subject. Here, no, we don't make B the subject. You have to go through the same process as you've done to A, right? So, Linda, what do you think will be the expression for B squared? And Linda.
Mr. Adrian, please, is it B squared minus C squared or B squared plus C squared?
This is B squared plus C squared.
Okay, thank you.
Okay, so B squared will be equal to A squared plus C squared minus 2 times AC times cos of the angle opposite to B, which is what? Beta. Regina, if I'm looking for C squared, what would that be? Regina. C squared. Hey, Regina, are you there?
Yes, please.
And what would be C squared? The same format. Okay, maybe Regina is still thinking about it. So C squared would be equal to A squared plus B squared minus 2 times AB times the cos of Regina times the cos of what? Times the cos
Alpha.
of alpha. And this is what we call as the cosine rule. This is the cosine rule. Yes, because what we have is not a scale drawing, we will use the cosine rule to determine the resultant. All right, so let's apply it to what we have at C. Can I explain it? Hey, where are they? Can I explain it?
Yes, please.
Okay. So we are looking for resultant R. Okay, but we will need this angle here. Okay, this line F2 is parallel to F2. Parallel lines have the same gradient or slope. But two parallel lines always will have the same gradient or slope. What it therefore means is that if we are saying this line is parallel to this line, then when I extend this, the angle from F2 to F1 must be the same as this angle. The reason is that because this and this are parallel and are equal. Are we fine? So if this is theta, this will also be theta. And if this is theta, what will be this angle? Yes. If this is theta, what will be this angle here? Anybody at all can answer.
180 minus theta.
Eliana, are you there?
Yes, please.
And you don't talk. So this is 180 minus theta. So we have the angle opposite to the resultant. And so we can apply the Pythagorean, the cosine rule. Okay. Okay, Eliano, help me get an expression for R. Yes.
R squared is equal to
Mhm.
F1 squared plus F2 squared minus 2F1 F2 cos 180 minus theta.
Good. So it implies that R, which is the resultant, is equal to the square root of all this. So if the angle is acute, this is how to determine the resultant. Linda, do you have any question? Regina, any question? Okay, an addition. You see this angle cos 180 minus theta. We can expand it. This is what we call a compound angle. Compound because it isn't only one angle, but one angle minus or plus another angle. So we can expand it. So please fasten your seatbelts and let's expand it, okay? Pay attention. Now, if you have two compound angles and one subtract or is subtracted from the other. Example, if you have cos of A minus B. So here we have two angles A and B. B is subtracted from A. Are we fine?
Yes, please.
Okay, so let's expand it. The rule for expansion of this is that it's a formula. This is equal to the cos of A times the cos of B. Now what is here is minus. So it changes to plus. If you have minus here, it will be plus. If you have plus here, it will be minus. Okay, so plus sine A times sine B. So this is the expansion of for cosine when it comes to compound angles. If you have cos of A plus B and you are expanding, it becomes cos A times cos B. What is here is plus. So we change to minus sine A times sine B. I hope all is well. Let's apply this to what we have. Cos 180 minus theta. Benita, help me expand this.
So it will be cos 180 times
Sine no.
cos
Cos 180 times
cos theta plus
plus
sine 180 times sine theta.
good. 100%. Now, what is cos 180? Cos 180 is equal to -1. If you have calculator, punch it. -1. So we have -1 times cos theta, giving you minus cos theta. Plus sine 180 is equal to 0. So this is equal to 0. This is negative